Oh, goodness gracious. I don't know why it looks so bad in mine, and it's wrong. When I printed it, it's wrong. I think yours has a correct one. Time to refresh my pages. It should look like that. Should I do this one? Are you guys interested? And it's again asking dx first, dy first, dz first. But here's shaded. So basically, what you have, let's go dz first. dz, the two surfaces, I'm going to go a little faster because I think I took my time in the last one. Is that okay? So dz first, I'm going to start. I see that the top surface is just y plus z equal to 1. Do not intersect, just solve for z. Z is going to be 0 to 1 minus y. Then I can see that on the xy plane, the projection on xy plane is just y equal to x squared. Right? It's y equal to x squared. And now, let's say I want to, because what? Sorry, guys. Y equal to x squared, and I do it that way, right? Y equal to x squared. And then the other part is when y plus z equal to 1 intersects y equal to 0. So this one is y equal to 1. That's when this surface, do you see that? This surface is intersecting the xy plane. And so that's where I get this shape. And then I go with this direction, starting y starts with x squared and goes to 1. X goes from -1 to 1. There we go. One more. Which direction this time? Funky direction and in a y direction. Let's do dy. In dy, I see there are two walls. Surface y equal to x squared and the surface y plus z equal to 1. A lot of times for the most inner, people try to see which surfaces include that variable. See y equal to x squared or y plus z equal to 1. And that gives them an idea of which walls that variable is hitting. And so dy hits x squared and 1 minus z. Now, what is remaining on the, basically, now you have to figure out what is missing, x and z. To find the, I forget that down at the bottom is not showing. So I want to figure out x and z. When I'm figuring out x and z, then I have to sort of intersect. See, I want to see how big that is, right? That shape. That creates the most shadow on the xz plane. So to find that, I have to set basically eliminate y. See, y was the most inner. I have to eliminate y between these two surfaces. So I'm eliminating y. And that is what? Z equal to 1 minus x squared, right? That took me a while. And so it looks like that. And x goes from -1 to 1. Z equal to 1 minus x squared. And I think this is a good direction to go. And so it goes z between 0 and 1 minus x squared. And then again, x is going to be from -1 and 1. Are we good so far? You guys want to see one more iteration? All of them? Okay. There we go. Now we do dx first. So that was, I didn't put it in there, dy first. And now let's do dx first. Okay, dx first. That would be interesting, right? See, there's this wall and there's the back wall, right? Both of them belong to y equal to x squared. But one of them is when x is in the negative side. One of them is when x is in the positive side. So if I'm solving for x in here, I have to consider both of them. So both of those are in this story. The square root of y dx, right? And then what is remaining that falls into the xz plane? For xz plane, I have a bad feeling. For yz plane, x is already used. For yz plane, what I have is the intersection of the two, and I want to eliminate the oh no, here. What I have is that line basically. It's the maximum is when y plus z equal to 1 is intersecting x equal to 0. So I have y plus z equal to 1. The most inner can be x or y or z. It doesn't matter. The same level of difficulty. 0, 1 minus y. Y runs from 0 to 1, obviously, in the picture. Okay, questions? Or did I go too fast for the last piece?
Should we expect to receive a picture, or we probably going to end up having to make our own, at least the three-dimensional?
Mark, I didn't hear anything you said. Can you say it again?
Will we expect to have a picture along?
Yes, yes. I'm a firm believer in having you guys see the pictures. Otherwise, it becomes too much of a trouble. Again, I don't, I never was into the algebraic solution for this because it takes a really long time. And seeing the picture helps, and I'm going to give it to you. In the real life, you guys will see those pictures, right? When you're doing these problems, there are pictures accompanied with these things. Maybe not for the double integral, for triple integral. Double integral, I have you draw the picture, but the triple integral, always you see the solid. Fair enough? Shall we go?